Hey everybody, forced airs and forced air systems. Looking forward to this presentation from Bruce Stahlberg. Just a little bit of background about Bruce, or maybe Bruce and I. I've known Bruce for years, and he's kind of a go-to for all these kinds of things. And a story I like to tell folks is when I bought a 110-year-old house about 20 years ago. Bruce was my first energy assessment, energy audit with a blower door in that old house. And I was feeling pretty excited. I put in some insulation. I'd done this and that. And I thought I'm going to go through this pretty well. And Bruce gently took me aside and said, "Hey, Joel, do you mind if I take pictures of your refrigerator coils?" In which I was like, "Oh no." And yes, he was going to use my refrigerator coils as a before and after shot of how gunked up refrigerator coils could be with cat hair and all this other stuff from the previous owners. So at the time, I was like, "Bruce, please don't say those are my refrigerator coils." But now I love to tell that story.
There's no slide with your name on it. No judgment. No judgment.
These are Joel's refrigerator coils. Anyway, today we're talking about forced air heating and cooling systems, and if folks are testing airflow or static pressure. And if anything, I'm just going to say, take it away, Bruce, and let you run the show from here. And I'm going to ask folks to save your questions to the end of the presentation. We've left plenty of time at the end to kind of really geek out and ask as many questions as you want of Bruce, but let's save those to the very end. Okay, thanks everybody, and Bruce, take it away.
Sounds good. Thanks. Thanks, Joel and Maggie, for all your work. Boy, I don't know how many months ago I reached out to Joel and I said, I've been doing this testing on furnaces, and it's really it's kind of a game changer. It's really helpful. People should know about it. And we kind of, got busy and got busier, and finally so here we are today. So thanks again for the opportunity. Just a little bit of background on me. I have probably tested for quality installs, furnaces, probably about 1,000 furnaces. So I have a lot of experience of what you see out there. Actually, I believe I got a seed grant way back in the day, and it was for static pressure testing. And that truly was a seed grant. I've been doing static pressure testing for a long time. So we're going to talk about that as well today. And today's topic is all about furnaces or forced air systems. So this is not a boiler system with piping or anything like that. All those systems, they use ductwork to blow air. Pretty common system that we find out in the field. So this is a picture of a forced air system, and we have what's called the supply ductwork. That's where the air comes out. If you put your hand on it, you'd feel the air blowing on you. And then there's a return ductwork, which pulls the air back to the heating or the cooling system and reheats it or recools it and sends it back out again. I've had customers sometimes tell me there is no air coming out of this register whatsoever. And I have to explain to them that that's a return side, so it's working as it's supposed to. Now, the big thing here is we like to see this completely balanced. So the amount of air that's coming out of the supply is the same that's coming back in the return. That doesn't happen often, but that's our desire. And this is kind of where we've come with furnaces. On the left, we have either a natural draft or a fan-assisted furnace. These particular furnaces were pretty simple, just a heat exchanger, one heat exchanger, usually pretty large. Often back in the day, there was not a lot of air conditioning, so the air could easily move through the ductwork system. And then we come along and say, well, you can get more efficiency, so we install a high efficiency furnace. And these types of systems have a secondary heat exchanger. They require a lot more air. So that's a major change in the system. So here's an example of that. This is kind of rough numbers, but the furnace on the left required about 100 CFM per 10,000 BTUs. And the one on the right is 150 CFM. So if you think about that, if we had someone that came and matched the output of the furnaces and said, we're just putting in the same, but it's a high efficiency, we would have more pressure in the system. Now, one way to think about this is take a straw and if you're blowing into it, but now you put like a very large blower on that straw and try to get the air through there, the pressure goes up. Um, Pressure is not a good thing. It's like blood pressure. We're going to talk about that a little bit later, but we got to be careful when we install new systems. So part of all of this is sizing. When you get a new furnace, it can be sized by how many BTUs, or in this case too, with the tonnage of cooling, what's it going to provide, what size it is. And historically speaking, everything has been oversized. The industry just always wanted to make sure that it covered itself, so they were oversized. And oversizing isn't very good. Now, this is sort of I have 3 different homes here. Obviously, they're all quite different, but each one of them would have a different heating load. Obviously, the one in the middle, kind of a split level rambler. The one on the far right looks like a 2.5-story old home. We should really be doing a manual J calculation to determine what size the systems would be. Now, why do we need to even have heat in the first place? Obviously, what happens is there's heat loss. It's a natural occurrence. The cup of coffee on the left, if you leave it out in the room temperature, eventually it will become room temperature. Nature likes to equalize those. And the same is true of our homes. We have what's called heat loss, and it's measured in BTUs per hour. And that's exactly how our furnaces are rated, how much heat loss per hour. Now, that number, the amount of the load is dependent on a lot of different things. The square footage or the size, how much insulation we have, how tight it is with infiltration, and then what is our design temperature. Now, for example, we often use 70 degrees, and this is for heating, on the interior temperature, and say we want to keep it around 70 degrees. The exterior temperature, which we don't have control over, can vary from town to town. And the next slide shows all the different towns in Minnesota and the various winter and summer design temperatures. We do design for the very worst case scenario. So for example, let's take Bemidji at minus 26 degrees Fahrenheit. This is according to the ACCA, Air Conditioner Contractors Association Design Manual J. Now, some days in Bemidji, it is 26 below, for sure, but not that often. And so what we end up doing is sizing our systems for the very worst conditions, and then that we're able to cover it. But the rest of the time, we're going to be slightly oversized. Now, notice Blaine has -4 and Minneapolis is -11. I believe that the city of Blaine may have adjusted it to go down a little bit to kind of make it a little more realistic. And I actually think that's a great strategy. Over on the left, the sentence says the above heating equipment will keep the home at an average temperature of 70 degrees inside, at an exterior temperature of 85 below. Now you think that could be a typo. That comes from a mobile home, and I've never been able to get an answer why we have 85 below design temperature, but it does seem to me that the furnace is going to be oversized if you're designing to 85 below. I like to say I lived in Crookston in the 70s and I still didn't see 85 below. So it's pretty important that we get this right, or at least reasonable. And so it's called a manual J load calculation. It's part of the ASHRAE standard. There's certain software programs that work on this. Why is it so important is because the airflow that we're going to need for the size is impacted by that choice of the size we put in. Oversizing, again, very, very common. It's getting a little bit better as we push contractors to kind of look at it a little tighter. It can create excessive pressures. So it's really important to make an accurate and reasonable manual J calculation. I'm going to tell you, I had one contractor, I pushed back on his calculation, and he said, yes, I know we oversize. It's just a very hard habit to break. And I said, well, that's really not a good enough excuse for me. So let's take an example. This is a home. It was a fourth ring suburb. I was at my desk. I saw the size of the furnace that they put in. And I looked at this, I pulled it up, and you can kind of see this is usually a fourth ring suburb would be 2x6 construction, fairly new. So usually pretty tight construction in 1995. Not a huge home at around 1,100 square feet. And it's a middle unit. So that's important because on all three sides, we are going to be having another home that's heated at, 65 to 70 degrees. So would the heat loss be high or low on this unit? And in my opinion, it'd be quite low because we don't really have much of a load here. So I went out there. The weatherization, this had actually been weatherized by the agency, a local agency. They came up with a heat loss of 20,000 BTUs. Cool Calc, which is a manual J software, I don't actually like it that much. I think it oversizes, but that particular modeling program said 32,000. There was a furnace proposal from another contractor for 36,000, and the furnace that got installed was 52,000. So I looked at their calculations, found a number of errors, and I went back to the contractor and I said, you know what? You oversized it. It's too big. There were errors in your manual J, but what we could do is if we set this furnace to run on first stage only, and in the future you just do a better job, I'll go ahead and pass it. So I kind of gave him a pass, trying to work with them, say, just let's be more careful in the future. By the way, this one was really loud. The owner noticed that it was loud. It had high pressure in it. So I called her back and she said, well, yeah, they came and put a new furnace in. So the contractor ended up installing a whole new furnace, a smaller one. And he didn't tell me about it, which was fine, I guess. But the profit margin seems like it would be, seemed pretty hard to put in two furnaces. By the way, we had 15 below. And I called the customer and she's like, yeah, it's just fine. So it passed a real world test, and that's the best way to really test. So oversizing is a problem. They can be very noisy. Short cycling, it'll come on, satisfy the thermostat, turn off. You get more repairs, increased pressure in the system, reduced efficiency, shorter life cycle. When something comes on and off a lot, there's going to be more repairs and shorter life cycle, and less comfortable. So there's a number of really good reasons why we want to get the sizing more accurate. Here's another example. The contractor's manual J used 2,800 square feet. This was a simple Rambler home, not that big. So I went out and measured it. 864 square feet per floor. Now, I actually included the basement, which I kind of wonder whether or not we need to do that, give that the same amount of weight. But at any rate, I used that number. The contractor installed a fairly large furnace, a 60,000 BTU unit. It was two-stage. I measured the airflow. I'm in the middle of something. Sorry about that. The airflow was measured at 203 CFM per ton, which is very low. That would make a risk of the coil freezing up. But more importantly, the static pressures on the heating side were 1.32 and 0.87, which was really much higher than the manufacturer wants. And then again, the owner complained that it was loud. We did go back and adjust this one and made it right, but that's something that we caught on the contractor's manual J. This is another example. I went out to a home to check the water heater, looked at the furnace. It was a very large furnace at 100,000 BTUs. Owner complained about it being loud, and I set it to run on first stage only. So we went from 93,000 BTUs down to 61,000. We had temperatures that dropped down to 12 below and 15 below. And I talked to the contractor, or excuse me, the owner, and he's like, it's just beautiful. It heats perfectly. It's not so loud. It doesn't wake us up. So it was a very easy tweak without replacing the furnace. He thought that they had many repairs over the 15 years, and he thought that might be why. That little speaker icon, I don't know if it's going to work, but I sometimes record owners and tell them so you can hear their story directly from them. Okay, I'm here with a homeowner that had a 100,000
There we go.
BTU furnace, and it's a two-stage, and we set it to run on the first stage. How did it go?
It was fabulous. It's quiet for the first time and it doesn't flash on, flash off, you know, like it does. That was probably that repair.
Probably
You
was,
know,
yeah.
and then, but having it quiet, you can hardly hear it.
That's great. How about when it was 12 below? Did it heat your home okay?
Everything heated perfectly. It's just been amazing.
So that's great. You know, the owner just was very happy with it. We didn't replace the furnace, but we can do this right from the installation time and get it right the first time around. Okay, so what creates restrictions in our system? And there's all kinds of different things. We have registers, ductwork, filters, coils, many different things. All of these things create pressure differences in the system. And so we have some selection choices that we can do on some of those. So everything that gets in the way of the airflow will create some resistance. Filters, obviously, we have lots of different choices of filters. Our blowers, heat exchangers, I mentioned that the furnace now has 2 heat exchangers instead of 1. The second one looks like a car radiator, so it's very fine, or it looks like an air conditioning coil. We know a lot of people have air conditioning. That's a trend that's happening for the last few decades. And then like on the left, the wooden register is more of a design register, but that cuts down the flow as well. So that can impact the flow rates. And, you know, as a consumer, you go out to pick a filter, there's a million choices, which is the right one. They don't often equate that filter choice can really hurt your furnace operation and your air conditioning operation by cutting down the flow rate. The filter on the right is one that I like, not so much the brand name per se, but just the fact that it's a 4-inch filter gives us a lot of good filter options without as much static pressure. Yeah, and this is, you know, as a consumer, I might say, I want to get rid of smoke particle for my family or pet dander, but that can have a real dramatic impact. And I often tell people that your furnace is not an air cleaner. It's designed to deliver heating and cooling, and that's how we need to set it up. Okay, so part of this description was static pressure. And so what is it? Well, simply put, it's just the amount of air pressure in the ductwork. More importantly, why does it matter? So I'm not going to do this right here, but you can go and onto YouTube. It's about a 3-minute video on static pressure explained. This guy does a really good job of explaining why we want to take a look at this and how it can impact our HVAC equipment. But the manufacturers definitely think it's important. They put it in the nameplate. And more manufacturers are taking a closer look at this because it's found on the nameplate, but it's rarely tested in the field. And I think anyone that is in the HVAC industry would confirm that. We do a lot of one other measurement called temperature rise, but rarely is static pressure measured. And it rarely hits the manufacturer's specifications. Most of the furnaces are rated at 0.5 inches of water column. And you'll notice that building scientists work in pascals. The HVAC industry works in inches of water column, but you can interchange those two pretty easily. So I sometimes will call the manufacturers of furnaces just because I'm getting results. I talk to contractors, they have an opinion. So I really want to hear right from the manufacturer. And this guy said, at higher static pressures, there's an increased risk of burning out the motor, reducing the life of the system, and requiring more repairs. So why don't we measure it? It seems like when we install a new system, we don't want to leave it in this way that we're going to shorten the life of the furnace, or create more repairs and more issues. There's also some other advantages to doing static pressure testing in that it's very easy to do it. It takes about literally 5 minutes or less. It gives us valuable information. It's accurate. It's quite immediate and accurate, and it helps us make decisions on how to increase the performance. What kind of tools do you need for doing static pressure? Well, we need a step drill bit. Those 2 bits there are called step drill bits. The reason that's important is you notice that they have little intervals, so we only go in a little bit at a time. That helps you control how far you're going in. I would never, ever use a regular drill bit because once you go through the metal, it can pull that drill bit into the cavity and you might hit like an air conditioning coil or something else, heat exchanger. So don't use that type of drill bit. In fact, the Energy Conservatory now has a new drill bit that goes in, I think it's like 1/4 of an inch, and you can't go any further. So that's another way to prevent that from happening. We need a static pressure probe with a magnet. That's the one on the upper right hand with the green hose on it. A manometer, which is a pressure gauge. All HVAC contractors should have pressure gauges. All weatherization people certainly have them. And then we want something to plug up the test ports. Now notice I call these test ports. That's an important distinction. We're not drilling holes in the systems. People sometimes get upset. They have a brand new furnace and you're putting a hole in there. So I always call them test ports. And you tell people that, hey, you know what, these test ports should already be here. We need to do it to get the furnace set up. And that will get you out of a lot of trouble, a lot of uncomfortable conversations. So always get in your mind to call them test ports. There are 4 different spots that we do this. One is in the return ductwork before the filter. The second one is after the filter. The third one is before the air conditioning coil, if it exists. And the second or the fourth one is after the air conditioning coil. So 4 different test ports. Now notice I'm going to go back here. If you look at number 1 and number 2, that's 2 different ports over the filter. That will tell you how much the filter is eating up, and that's called a pressure drop. You can also do the same thing on an air conditioning coil, and it kind of gives us a way to determine whether the coil might have a problem with being plugged. So that's called a pressure drop. And the difference across 2 measurements, it can isolate the filter or the air conditioning coil, and it can determine if it's a return or a supply issue. Here's an example. I'm going to try to do this. So notice my measurements are -0.25, -0.59, 0.34, and 0.21. The first 2, we subtract those because it's a pressure drop. And coming in at 34, that's a little bit high for a filter. Doing the same thing across the coil, we got 13, and that's pretty good for a rough budget of 20. And then the total static pressure, which is TESP, we add those 2 numbers, and that's 93. So we ask, well, with these numbers, where might we improve this system? And we could probably try a different filter to get that number down and then retest it out and see what happens. Also, by the way, when you're talking to owners, do not talk about 0.21 inches of water column. It's always better to use whole numbers. So I would fail every well, about 95% of the furnaces if I required 0.5 or less. But if we get there, that's really great. That's what the manufacturers want. If we, I allow it up to 0.75, I'm still okay with that. If we get above that, we need to start looking at changes, and anything above 1, we'll never pass it, and we need to make an acceptable alteration. And this is based on a conversation with about 30 different contractors, so it's nothing scientific other than what people's opinions think. When you're talking to customers, be sure to use blood pressure, and just say, look, your furnace has got twice the blood pressure that it should have. It's going to hurt the life, so we want to make some adjustments on it. Imagine going to the doctor and they took your temperature but didn't take your blood pressure. That's what we're doing with our systems. And so always kind of bring it back in a way that's a little bit easier for people to understand. Okay, now the things that we're looking for with our quality install is the proper sizing. We talked about that. Proper airflow, which is actually very easy to measure, and proper refrigerant, which as a technician, I don't have the ability to measure that. That's more of an HVAC technician. But airflow testing uses the exact same test ports that we talked about with static pressure. Now, if you want to just get started, I think it's a good idea just to measure static pressures. But if you happen to have this tool, you can take another 3 or 4 minutes and get an airflow, which is really a critical thing to do. Especially when we're installing something new, airflow is really an important thing that we do not measure currently. It gives you a detailed report that you can email. It's very visual. And Maggie put a link for the app in the chat box. And so what you can do, it's a free app. You can download it. You can run a test on demo mode under settings, and you can see exactly how it works. And if you want to show your boss or someone else, how this thing works or why you might want to consider doing it, you can run it on demo mode. And then this link here gives a short video on how it actually operates as well. Okay, so I talked to a lot of contractors, and this breaks all the rules of PowerPoint presentation with having these many words on there. But it was interesting because I called them up and I said, the airflow is really important on this. This one's got low airflow. Are we doing the client any favors we might freeze the coil? And he said to me, now that you're asking us to check the airflow, there's going to be an additional charge for going back. The reason I put this in there is I thought, really, that's part of the system for setting it up. So we work with contractors now that they know we measure the airflow. Many of them have purchased a tool to do so, and we're trying to catch everything on the front end without reworks. Desired airflow for cooling coils is 350 to 400 CFM per ton. So remember, the sizing comes into play. If that's a 2-ton unit, we're looking at 700 to 800 CFM. In the past, 400 CFM has been kind of an industry standard. But the closer we get to 350 gives us a better dehumidification, which is really what we're trying to do with air conditioning. We're trying to dry the air out. So there are different ratings for the coils that you can get into a deeper dive on this. But if we go too low, we can freeze the coil. If we go too high, we lose dehumidification capability. So here's an example. A new furnace was installed in the winter of 2024. In the summer, the AC wasn't working, water dripping all over the floor and not cooling. Owner explained they had never had this issue prior to the new furnace. Somehow I got involved. So I went out there, we did an airflow test. System was found to have very low airflow, was freezing the coil. That's a picture of the coil there. You cannot blow air through ice. The airflow was adjusted, and told the owner to notify us if they have any issues, and we haven't heard from them since. But this is what the furnace looked like. they made tinfoil channels to make the water go away from their furnace. So this is not what I would call a quality installation. The picture on the right, there was about an inch of water in the bottom of the furnace. So this was not a good installation. So it all had to do with the setup. They put the new furnace in, they got heating. We just didn't think about the air conditioning at all. So that's not what we want in a new installation. So here's what happened. We tweaked the blower speed. We remeasured it. We got it up from 285 to 358 per ton. Notice the static pressure went up as well. The problem with this system, it was an air conditioning system that was way oversized, but we weren't changing the air conditioner. We're just doing the furnace. So we had to struggle with that. I've been told that the airflow is more important than static pressure, so we had to kind of live with it. I just told the owner that when they replace the air conditioner, they should resize it. Here's another example. My initial inspection on a new furnace. Actually, no, this was before anyone got out there. It was kicking off on high limit, meaning that it would turn off after a few minutes. She said they had lived there in a freezing cold home for 7 years. She told me sometimes they wear their winter coats in their home. We had high return static pressure. That was 0.71. That was no filter in that, so that was all the ductwork. I called out for more return with the new furnace. I went out to do the inspection. They put in a new furnace, but somehow there was no more return ductwork added. I wasn't quite sure how that happened on our work order. The airflow was low on the air conditioner, so I wrote up a rework. We added a return duct, and we set the first stage to run for a long period of time. What that means is, in this case, it's a Goodman furnace. You can set it up for 60 minutes, and that kind of buys us a little bit of time. So it may not ever go to second stage, but if it does, it's after 1 hour, and it's going to be a much less run time. I called the owner. She said it works great. So the point of all this is if you don't test, if we hadn't done these tests, we might have just put a furnace in and had the same problems all over again. So you got to verify on the inspection process. Let's see if the speaker comes up on this one. I'm at household 941805. Yeah, can you tell me how the house heats in the wintertime?
Oh, it is really freezing cold. Even I put on 72 Fahrenheit, but still really freezing. So we put more clothes on in the winter.
Okay, and do you find that to be, what if the temperature is, say, 20 degrees? Is it still cold in here?
Freezing.
Okay.
Sometimes even our water's not working in the shower tub.
Oh, because
Because
it
if it really
freezes.
freezes, yeah.
Okay.
It's so cold up here.
And then probably when it gets really, really cold, like 20 below, you have problems again?
Yeah, it's mold.
Okay.
Yeah.
Okay, thank you.
Thanks. Yeah.
Okay, so that home, on the start, definitely a problem, right? I don't know any of us would expect that we should wear our winter coats when it gets cold out. We have heaters for that, so. This one here is a mobile home furnace. So kind of the same thing happens with mobile homes. Although the ductwork is much smaller, so our issues become even greater. Static pressure is only rated at 0.3 instead of 0.5. In this case, we took out an old 80% furnace. The static pressure was actually pretty decent. That was the existing column. And then we put in a high efficiency furnace, and you can see that static pressures went up to 1.4 inches. So it was very loud. And on my inspection, this is what I found. So we're at a home where we just installed a 2-stage mobile home furnace. And I'm talking to the owner about any changes that were noted from the old one. Have you noticed any differences between this one and the other one?
This furnace seems to be much louder. When it kicks in at night, it's loud enough that, sometimes it wakes me up or it's hard to sleep. Other than that, it does, seem to work as far as keeping everything, warm.
Okay. And then when it was really cold out, it was able to heat it. We had a 15 below temperature.
Yes, I tend to keep my thermostat low, so it's kind of a little chilly, but it did, keep it at the, I think it's 62.
Okay, thanks so much.
Okay, so I don't know about you, but some nights I don't sleep all the way through the night. But it shouldn't be because of my heating system and the work that we did. So I called the contractor back. The furnace seemed to be very oversized, so we were running it on first stage only. Means you paid for a two-stage furnace, but we got one stage. And here's what the result was on the second part of it. So we're at a home where we installed a furnace and we had to come back and do some tweaking on it. Can you tell me any of the changes that you've noticed?
Yeah, so the furnace is much quieter. It doesn't get that loud noise that was waking me up. I've noticed that even with the rising cost of gas, my utility bills now are lower than they were last winter. So it's been working really good.
Good, well, good, glad to hear it, thank you.
So I feel much better about leaving the job, something like that. You know, it's nice to have heat, but we shouldn't be waking people up as kind of a balance or a trade-off for that. This one, there's no audio on this one, but the very first visit, we had airflow. Actually, the airflow per CFM was spot on, 372. I'd be very happy with that. Our filter drop, not much at all, so that was really good. The AC drop over the coil was over 1 inch. So just the coil itself is more than twice what the manufacturer recommends. So that's a problem. And now what this is this kind of allows me to get an eye, or at least kind of know that the air conditioning coil has got a problem. So I carry a snake camera and I was able to get a picture up in there, and you can see that there's a lot of dirt on that air conditioning coil and it's plugged. So we could put a new furnace in, but we still can't get rid of the heat because we have a major blockage right above it. Post work, we did an inspection, and what I had called for is cleaning the coil and putting in a better 4-inch filter. And we did a test. Our airflow came in a little bit high at 446, but you can see the AC drop was way better at 0.29. So that told me that they did get in there and actually clean the coil. So I tweaked the furnace, slowed down the blower motor a little bit more, and we came in at 389. And this is actually really good numbers. Notice that the pressure is more than 0.5 at 0.64, but I can totally live with that. And I feel like this system is going to work much better. One more example here. This was a publicly funded furnace. We put in, I went out to do the inspection, and I noticed that the return readings were very high. Without the filter, it was rated, that was 0.71, with the filter 0.86. Supply, not really a problem. So this was all on the return side. So I went upstairs and I noticed they had put some new flooring in. So I asked him, I said, did there happen to be some registers in these areas? I could see where the ductwork was originally used to be in the basement. And he said, yeah, we didn't know what they were for, so we just went over them. So I told them about that. They went back in, they cut them back in. I didn't get back out to retest this, but we did put in the original returns. So, this is a publicly funded furnace. Contractor didn't do any of this testing. So really what would happen eventually, this furnace would burn out probably 5 to 8 years when we expect to get 20 years out of them. Okay, so I gave you a bunch of examples. You may have questions. I think really this is just a taste. We could do probably a 4-hour seminar on this. But I just think it's really important that we all start looking at this a little closer. It's easy to do. It takes a little bit of training. But once you start doing it, it's really important, and you'll find that it's an easy and really good test. So first of all, when you get a manual J calculation from a contractor, it's okay to scrutinize those. They often do not measure up things. I've had them out to my house before. They don't measure, they don't look in the attic, they kind of, rule of thumb. So that's okay for you to scrutinize those. I can kind of safely say that if it's a Rambler, the furnace could be 40,000 BTUs, probably a 1.5 ton air conditioner. Those are kind of rules, but we often see them much larger than that. Start measuring static pressure and pressure drops. Ideally, you get the equipment and start performing airflow testing. If you're a weatherization agency, you have the Bluetooth gauge already, so your expense of getting into it is not that much. You don't have to buy as many things as maybe a contractor would have to do. But even so, the price of these things is not that bad. Let's see, I would spec out 4-inch filters. If you have room in the return drop and you're replacing the furnace, it's a very good time to add a 4-inch drop. Include ductwork adjustments. If you do static pressure testing and you find that there's a problem, I would go ahead and say, hey, we need to add another supply or get more return. And then you can also try to run, if it's a 2-stage system, try to run it on first stage. If your numbers don't look good on second stage, try to run it on first stage as long as possible. And just verify the installations. So we are required under weatherization, DOE and the State Department of Commerce to do temperature rise. That's actually a pretty weak test. There's a number of things that there's probably 5 or 6 different things why that isn't as very accurate or as good of a test as static pressures is. So that's it. I'm open for questions. There's my phone number. My goodness, I just put that right out there. Don't call me at 3 in the morning or I will block your calls, but if you got questions or if you're looking for trainings or anything like that, this is a really important thing to do for us to start to get it right. I work with some agencies doing ERR inspections, and it seems to me that like the furnaces just weren't lasting very long. And the directors thought they were getting 12 years. I mean, we aren't tracking it that closely, but 12 years instead of 20. If you get a system set up correctly, it should be quiet, it should be effective, it should last a long time, and you shouldn't have many repairs. And that's about all I've got.
Bruce, thank you. Now is the time to open it up for questions. Folks can put things in the chat or don't be shy. I think you have the ability to be taken off of mute and ask Bruce a question.
And you can always know that if you've got a question, probably somebody else has that same question. So you can be the hero and ask it.
I have a question. There's a move towards installing heat pumps, and those supposedly require, well, have a lower temperature rise and therefore need a greater airflow. And is that causing a problem with ductwork?
Yes, this is kind of thanks, Tim, for asking that question. Kind of why it's important that we do some measurements, because when we're installing new systems, we are not changing the ductwork, generally speaking. We're using the original ductwork. Now, that app that you have access to also has a nice tool in there called forecasting. So if you're thinking about putting a heat pump in, you can use that app to determine what size would start causing problems in your particular ductwork without any changes. So you are right, as we put in new systems, particularly heat pumps, and we keep the original system, it's really critical that we get the airflow right, the static pressures right. Now I'm going to further say, when I used to talk to contractors about this, they said, well, Bruce, we're gonna have to tear out all the ductwork, and that's about $20,000. And I will say here now, I have never advocated tearing out all the ductwork. You can do that on the other side with your capacity. So picking a system that's going to match your ductwork. And so, did that answer your question, Tim? Is that helpful or?
Yes, thank you.
Yeah, and also further, Tim, and I think there's others on here that have a lot of heat pump experience as well. But you can also look up, what is the rating for the manufacturers of your specific equipment and what they're looking for. So that's kind of important to kind of get that right too. What I gave you is, kind of some general numbers here. Sometimes they're rated as high as 0.8, but every coil also has a recommendation of airflow. But right now, it's my experience that it's just not being done. Not without any frequency, and I'd say kind of across the industry, not done very often. When you talk about static pressures, most of the contractors are totally aware of it. Although I have had some technicians that say they went through school and didn't really get much information about static pressures, which is kind of crazy. But contractors are aware of it, they're not testing it. So when I go out to a system, I don't see the test ports. Our agency now is doing it with frequency. We're trying to get our auditors to do it on the front end of it. So one other thing I'll say is when I first started doing it, I was kind of terrified, right? I'm drilling test ports into systems, and there's certain tricks that you get depending upon the location of those. Knock on wood, right? But I have never, ever hit an air conditioning coil, a heat exchanger, anything like that. And like I said, those drill bits that I mentioned, you'd almost have to try to do it. So you can put that fear to rest. And once you start doing this, it's really pretty exciting to see the results. To walk away kind of knowing that you've really left that system in the best way possible. And with this report, you can even email that to the owners, and so then they can slide that in the little furnace slot, and we have documentation of it. Any other questions? Anything come up in the chat box?
Not yet. Anybody want to throw anything into the chat is fine as well.
All right, we got kind of a strong silent group out here, it sounds like.
The strong silent types.
That's right.
Bruce, I think you answered. I was going to ask a question, which was and I think you just answered it the last part. I was like, man, I think that very first time, and I'm a total, I'm not a professional in this at all, but that very first time I was putting in those test ports, I think I'd be a little paranoid. But I think you were saying like at that 1/4 inch depth, you should be pretty safe
Yeah. And I don't have a picture of that in my slides, but on the Energy Conservatory, you can go on their website. That drill bit literally goes in a 1/4 inch. So, and then they sell the plugs that go right into it. They've actually come up with another new little sticky thing that'll say test port. So it's actually labeled. So I've been starting to put those on there. So anyone that comes afterwards, they'll see the 4 test ports. So, but
cool.
and I'm not plugging the company. It's a Minnesota company. There are other ways to do it. You can buy step bits at your hardware store. You could even put a block on a regular bit, so it doesn't go in as far. I just don't think that's necessary with all the other tools that we have. So I'll say this: when I first started using an infrared camera, they were very expensive, but I bought one and I started using it. And then I sometimes did jobs where I wasn't required to use the infrared camera, but I really felt like, how do you do it without using that camera now, right? it was such a useful tool, and I find that with this, we aren't required under the state weatherization program to do these tests. So I spend quite a bit of time on this. There's not even a place to write it on the forms. But I can't really walk away without doing it because otherwise I don't really know. And I feel like I'm not doing a very good service.
Yeah, Tim, I think you might have another question. Please go ahead.
Yeah, Bruce, you, and your diagram, you labeled the test ports 1 to 4. Is that a standard numbering system or is that just ad
Yep.
hoc?
Yep. No, and maybe I can go back to that. Yeah, those 4 test ports are what they are what the app asks for on a typical furnace like this. Okay. Now, if there's no air conditioning coil, then it's going to be a slightly different screen, and you aren't going to have you won't have that fourth one because there's no coil. Mobile homes are a little different. If you play around with the app, you'll see that that's a downflow. And I've been doing some of those tests. It's a little more complicated than a single family. And sometimes getting on the opposite side of the air conditioning coil is a little bit hard to do. So it's not as straightforward. But to answer your question, generally speaking, and I normally do them in this within that order. So when I write it on a data collection page, if I see 4 of these measurements, they are in the order of before the filter, after the filter, before the coil, and after the coil.
Thank you.
Yeah.
Bruce, can you go one more slide forward? I feel like you had a
Yep.
nice graphic.
That one?
There, that one, yeah. I like that one as well. That helped me
Yep.
understand it as well.
And
Very good.
we've sort of come to laminating this and then sometimes sending out an erasable marker. So in the field, you could write your numbers down here if you're just doing static pressures. The other thing is, I think it's important. I think the data collection pages for mechanical should be, have a space for this. But every time I try to change a state form, people freak out and go, "Oh my God, you can't change those forms." So so we're trying to figure out where would somebody go if they wanted to know what the static pressure is, where would we look? So everybody's looking in the same spot. Seems like that would, have a spot on your form where that happens. So now the other thing, if you use the app, all the information is in there and I can email that while I'm in the mechanical room. So it's really pretty brilliant. I don't need to worry so much about documentation. And the app also has some other advantages. You can take some pictures in it. It does make the file a little bit bigger. There's a place to put comments. So I'll put what type of filter is in there. I have made a suggestion to them that they add a spot where you can put the filter in there because that way we would have better information about what types of filters are causing what types of pressures. But it's a nice app. And believe me, I'm a Neanderthal kind of guy, so using an app is like, wow, this is pretty fun, but not something I'm more of a paper and clipboard kind of guy.
Well, Bruce, I really want to thank you for this presentation. I know I learned a lot. I hope folks watch and learn some as well. I know you had your contact information on that last slide. So any last words of wisdom? If not, we're going to wrap things up.
Sounds good. Sounds good.
Take care, everyone. And thanks again, Bruce.
You bet. Take care. Thanks, guys.